Good evening and namaste. I am Ram Pt1 from Tiruvallur University, Central Department of Physics. So, in this conference, it is too technical and I was very much benefited by knowing or broadening my knowledge. But this research of the findings, what I am presenting, is focused on air person modeling. And for air this personal modeling, I have carried major scale methodological simulations. So I think it will be has some applications in wind energy assessment. So the motivation for this so Cartmel Valley should be clean like this, but nowadays it is blanketed by air pollution and fog, and you cannot see the cities, and from cities you can see the mountains. And occasionally, like Mukeshji was saying that government has planned to develop 20 megawatt of wind energy from in and around the Cartmel Valley, and there is some wind disasters, occasional wind disasters, and some of the identified sites, according to my findings, are not suitable for wind energy development. I will discuss on this. And these are beautiful villages, and I think if we can provide clean energy, they will remain clean forever. So this is my motivation to work in wind energy. So the terrain of Nepal is very complex. So this is about less than 100 meters, and it goes up to 7,000 meters, and this is the Cartmel Valley, which is located atop a mountainous region, and this is very typical. It is surrounded by lower valleys and plain areas, and it can be considered as a plateau and elevated plateau with a rim. And later I will show you that this shows a plateau based in dual nature. During the daytime, it brings regional air mass up into the valley, and in the night time, it accumulates deep cold airlet. So during night and daytime, it behaves as a plateau and as well as basin. So this is the Cartmel Valley. It is completely surrounded by rather steeply rising mountains and hills ranging from 500 to 1500 meters above the valley floor. I accept it as some low mountain passes in the eastern region part and in the southern western part. And this is the single outlet. This is Bhagmati river flows, and this is the single outlet of this valley. So if you see the complexity of the terrain, we can expect that there is large number of subdivisions and subclimates. So the wind associated with these subclimates interact in a competitive manner. And I think to harness the wind energy, we need to resolve this interaction sufficiently. So this is the airport data from airport measurement, and it shows at the valley floor, and the wind is not strong. Most of the time, valley remains calm, and the maximum speed approaches around 4 meters per second. And this is the monthly average from January to December. You see, it is less than 2 meters per second, monthly average wind speed. So my calculation domain consisted triply nested two-way interacting meshes of 9 kilometer resolution, and the second domain is 3 kilometer resolution, and the finest domain is 1 kilometer resolution that covers the Cartmel Valley and its surrounding mountains. So this is the night and representative night and morning time wind system, flow system in the valley. This valley remains completely calm or windless from late evening to close to the afternoon. So, however, there is some wind in this drainage flow, and this along the Bhagmati flows, and in this mountain tops, wind prevails for the during the night time, and this valley forms a cold air lake of about 400 meters deep. So breaking this calm situation, long calm situation, two characteristic winds in the form of combined plateau and valley winds. Includes into the valley. It is approaching here, and from this side, this northwesterly and southwesterly wind. And they mix into the valley and forms a westerly wind, and there is a convergence zone, and it passes to the eastern valley. So in the late afternoon time, you'll see that the typical characteristics. This northwesterly wind is not proceeding from this side. So in this region, it makes a hydraulic jump and lifts off and goes over this southwesterly wind. So this is, I found, according to this simulation and also some observations, was that this is relatively cooler than this one. And in the evening, it forms a weak anticlockwise circulation and it becomes calm. This is the 24-hour animation of a predicted wind system for clear day case. You'll see that this region has most of the time it has wind. So it is almost 180 degree interval, day and night. And this region also has relatively, this region is also windy. And this region also, this mountain top, eastern mountain top also appears windy. But I will rather show that not all this area, this is another valley, so it also shows higher wind. And not all these areas, like according to the government or measurement, people have measured wind speed here, aiming to develop wind energy. And also they have measured in this side, but they have not explored this side, and they have not explored this side. So I'll show that this area is not suitable for wind energy development, and this area may not be suitable for wind energy development because there are wind warning, there be a high risk of wind warning disaster. So this is the southwest, northeast, this cross section. So along this line, AB, so vertical cross section of flood, and you see that Katun Valley develops a very stratified layer, and this strong inversion breaks off at 9:30 p.m. So 9:30 in the morning a.m. and it lifts off. This inversion lifts off, then wind inputs into the valley through the mountain gaps. And this I simulated for 1 week, and almost similar pattern I found. And this is the southwest, northeast cross-sectional plot around the river course. Again, it shows the similar patterns. And as organizer asked me to limit time, so I want to go fast. So this is very interesting picture, and this red contour shows the potential temperature of southwesterly wind intruding from the river course, and this is intruding from the western valley gap. And if I calculate the internal Faraday number, and it is shows that it is making idle jump somewhere here. So this is the region where that I showed in the initial this uprooting of the mature trees and that wind disaster. So it is exactly predicted, and this is the time. If you see the time, then it occurs occasionally during March and April in Kathmandu from 4 to 7 p.m. We have this kind of wind storm. And in looking for the why it causes, then this is about 1 kilometer high, and it's just above the surrounding mountain tops. There develops a strong stability. Just above that, there develops a weak stability. And in wind storm forecast criteria, this is one of them. When the stable layer develops just above the mountain tops and weak stability prevails above that, then that is an indication of severe wind storm. And I think we can also predict wind storm, possibility of wind storm in Kathmandu. And this southwesterly wind is rather shallow. Its depth is about 250 meters, and this is considered as northwesterly wind goes above the southwesterly wind. And this western mountains occasionally create a mountain waves, and that might hit the eastern side. And if the mountain wave can hit those areas, I think we should avoid huge area for the development of wind energy or the development farms. In the surface, there is no wind, but if I see the 150 meters above the valley floor, there is a weak anti-clockwise circulation throughout the night, and about 500 meters, there is strong wind, anti-clockwise circulations, and this shows a very complex wind circulation system over the Kathmandu Valley. And since when I was carrying this research, there were only single station at the airport, and there were no much necessary data. I carried some solar observations. This vertical profile is quite good, and this temperature and wind speed, average as well as the mass 6 case, it is well reproduced. And if you see the more larger scale, this is Nepal-India border, and this is Kathmandu Valley, this is Sunkursi Valley. In the daytime, we have a pronounced wind blowing towards the Tibetan or Plateau or Himalayas, but during the night time, like Kathmandu Valley, this Sunkursi, Christian Valley all remains calm. And the almost half or 3 times lesser than the upslope wind during the daytime, and in the night time it is 3 to 5 times lesser than the daytime wind. So this is just for your interesting case for air pollution. Like Kathmandu, the pollution remains confined within the valley throughout the night time at about 1 p.m. So it once crosses into the eastern valley, and then as the wind intrudes into the valley, because of the double layering structure of the wind system, it stagnates the pollution, particle dispersion is completely suppressed, and it forms a shallow layer of pollution. And this is the nitric acid case, this is the secondary pollutants. So this shows a very another interesting fact is that at about 1 p.m. it crosses into the eastern valley, but during the night time partially turns back and remains floating over the valley throughout the night till the next mixed layer develops. So now all this research I did in Japan. Now I am working in Tiruvallur University. So I tried hard to get some minimum environment so I can continue my simulations and some wind resource atmospheric research. As you know, there is 18 hours of load shedding in Kathmandu. So it was not possible to run computers for these solars. So university fortunately has provided with the solar panel and this battery bank. And this solar is contributed by UNDP. And this is a monostatic flat array solars and Syntec Mech. And this is a brewer. And this is a computer contributed by FOI Institute of Sweden. So a good friend of mine. So just gave me this computer. And only in the last week, I could do first simulations. So I want to show some research findings of that simulations. Let me show this. So this is the Pokhara Valley. And I didn't have time to verify this. So wind system of Pokhara Valley looks like this. So later on, after returning back to Kathmandu, I will try to verify the correctness of these simulations. And similarly, people were talking about the Mustang is the most potential area of wind energy development. So I also tried to do some simulations of that area. So this is more larger scale, and Pokhara Valley is somewhere here at the center, and Mustang is beyond this. Second slide, I can show it. So let me go fast. And this is the Mustang Valley, Taligandaki Valley. And this site is, people say that most promising site for wind energy development. And as though I have not verified this result, and this numerical simulation can be successfully carried out, and we can see the so many physics options, and also we can do solar observations and observational logic we can do, and also this data assimilations from over here, data available. I think we can